All right. Well, good morning, good afternoon. Welcome back. Happy Tuesday. Go ahead and take out your notebooks and start on the warm up. What we're going to do is something from yesterday. So, what I'd like you to do is write down the polynomial in standard form, but also tell me what the leading coefficient is. So, take some time to do that. And when I'll come back and review it. All right. Well, let's take a look at the warm up here. First thing I want to do is collect like terms and write it in highest degree. So I'm going to start with the highest degree terms first. I have my x squareds as my highest term. So if I collect those, you can do 2, 4, and 3. So we have 2 plus 4 is 6. 6 plus 3 is 9. So I have 9x squared. Then I have my x values here. So I have 3 minus 5x, so I have a negative 2x. And then I have my constants. So negative 12, negative 7 gives me negative 19, written in standard form. Now remember, the leading coefficient, we only care about the highest degree term here, and that is x squared. So if you just look at the x squared, the highest degree term would be 9, or would be 2, and the leading coefficient on front of that is the 9 here. So the leading coefficient is 9. All right, let's look at the second one. We're going to identify the highest degree term, and the highest one I see here is 3, and I see multiple, so I'm going to combine those, and I have 4 plus 7, so I have 11x cubed. Then my next term down is the squares, and I have 2 of those, so I have negative 5 plus 11, so that gives me 6x squared. Then I have my regular x's, and I just have one of those, so I have a plus 2x. And then I have, let's see what color I'm missing here, green. I have 3 and 5, so I have a plus 8. So this is written in standard form, and again, my leading coefficient here is 11. So my leading coefficient is 11. All right, let's look at the third one. Again, I want to identify the highest degree term first, and that is a 7, but there's only one of them. So I have 3x to the 7th. The next one down would be 6. I don't see any of those. I also don't see any 5s, but I do see a 4. So the next one down is here, but I also have a negative 3 of that. So I have 4 minus 3 gives me plus 1x to the 4th. I don't see any x cubes, but I do see some x squareds. I have 2 plus 5 gives me 7x squared. And the x's here, let's see that color. I have 11 and negative 5, so I have a plus 6x. And again, my leading coefficient, I only care about the first term because it's the highest degree term, and the leading coefficient there is 3. Why do I care about the leading coefficient? Why did we take time to pull that out? Well, we're going to need that today. So that's why we have to identify it. If you remember from standard form in the quadratics, we had ax squared plus bx plus c. A was a very special number in the quadratic section because it told us what the graph did, and something very important. It told us a few things. Remember, in quadratic section, it told us if the graph opened up or down, but it also told us, is it wide or narrow in relation to the parent function, positive 1x squared, right? So our parent function was x squared, and A told us whether it went up or down, but it also told us if it was wide or narrow based on the absolute value. So the leading coefficient is very important in a polynomial because it tells you what the graph does. So let's look at our essential question today. Our essential question is, I'll give you time to write it down. So our essential question is, I have graphed x to the 1, which is a line, right? Y equals mx plus b. And I've graphed x squared, which was a parabola. That was all the last section, the quadratic. But how in the world do you graph where the degree is larger than that? When I have x cubed, x to the 4th, x to the 5th, all the way up to x to the n, how am I going to graph a polynomial when it's not a 1 or 2? I know how to do a 1. I know how to do a 2. But past that, oh man, I'm lost. I don't know what to do. Well, today we're going to answer that. We're going to start to look at the basic characteristics of what these graphs do. And so I'm going to give you time to write this down. So go ahead and do that. All right, so we're looking at graphing polynomials, and I want to know, is there some kind of characteristic or pattern that comes up that I can try to be able to graph what these look like, and understand patterns. So in order to do that, what I want to do is I'm going to pull up a Desmos graphing calculator here, and just so you can see what we're looking at. Okay. So if we look at when x is 1, what do we get? We get a line, right? We did that y equals mx plus b here. M is 1 and your b is 0. So you just have a line that goes through the origin and it goes up 1 over 1. So that is your parent function of a line, is just x. Well, when we did the quadratic, remember we got x squared, we got a parabola. Quite a drastic difference in graphs, right? So you would expect then, well, man, x cubed, if I have such a drastic difference in a line and a parabola, how do I know what all these other shapes look like? Well, we're going to start to put these in and see what kind of patterns go up. So if you want to do this along with me, feel free. Go to desmos.com/calculator. I know you've used that before in this class, and start to see these patterns. So if you do the caret symbol, which is the shift 6, you can put in your power. So if you go x caret 2, you'll get x squared. If you go x caret 3, you'll get x cubed. So what I'm going to do is first I'm going to pull this one back off. Let's just look at a line. Notice in the parent function form, it's down on the left side and up on the right. So as x approaches negative infinity, your y value approaches negative infinity. And as x approaches positive infinity, so over here, as x goes to infinity, your line goes down to negative infinity. As x goes to positive infinity, your line goes towards positive infinity. So this is the natural order here. If we look at the parent function of a quadratic, remember, because you're squaring each term, a negative times a negative is always going to produce a positive. So it's going to take this from going down, mirroring this down, to mirroring it up, because a negative times a negative is a positive. So you're always going to have positive no matter what value of x you put in. Remember, we did the axis of symmetry. The quadratic formula gave us the axis of symmetry and said you're going to have the same plus and minus on each side. That appears here. But if I take a negative times a negative, I'll always get a positive. But think about the next degree. The next degree is 3. So if you have a negative times a negative times a negative, there are 3 negatives, your answer is going to be negative. So it's not going to come up here. So let's see what it looks like. I'm going to turn off the line and I'm going to put on x cubed. And notice what happens to the graph. So I get something similar to a parabola on the right side. It just looks like a steeper parabola, right? Because I'm cubing that term. For every input value, I multiply that by itself 3 times. So it grows significantly faster. So if I zoom out here, you can see that it just grows significantly faster. than the x squared value. Now, because I have a negative times a negative, I got a positive over here. But the moment I add another negative, I flip down to a negative. So it's going to do the same pattern that it would here, but in the negative direction. So it's almost like you cut the parabola at the vertex and flopped it down. That's what happens when you have an odd term. So these are going to start to develop a pattern, and we'll see that. Because you have negative times negative in evens, you're always going to be positive. My even number degrees are going to look similar to the parent function of x squared. Similarly, my negative times a negative, if you have an odd number of them, it's going to be negative. Anytime you have an odd number, so 3, 5, 7, it's going to look very similar to this x cubed graph. So let's start looking at this. I'm going to turn off the x cubed, and we're just going to look at the evens now. So I have a square. I have a to the 4. Notice it just grows really quick. Grows even quicker. Grows even quicker. But notice, because I'm multiplying these on the right side, they're always going to be positive. But the negative side, since it always ends up being an even number of them, they pair off with each other. They produce a positive value. So anytime you have a polynomial with the highest degree term, notice I only care about the highest degree, that first term. The highest degree term, if it's even, your graph's going to look like this, where it goes up and up on both sides. Now let's see what happens if I uncheck these, and let's look at the odd version of it. So obviously the linear, same thing. Negative produces a negative, positive produces a positive. 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 So no matter what the polynomial is, if it's an odd number, because the negatives don't cancel out and you have that one left over, no matter if it's 1, 3, 5, 7, if you pair off the negatives, you're always going to have one left over to produce a negative answer on this side. So they look really similar to parabolas, except for you cut them at the vertex and you flip that upside down on the left side and they go negative. So since we've noticed this pattern, what we're going to do is kind of create some rules. But before we do that, what I want you to notice is, let's go back to the section of linear. What happened if I had a negative slope? Do you remember what the line would do? Now we're taking the inverse. So hopefully you said it goes the other direction, right? You flipped it the other direction. So a negative doesn't produce a negative. A negative then would produce a positive because you're taking the inverse. And a positive doesn't produce a positive. It produces a negative. You're taking the inverse. So let's see what happens when the leading coefficient of a polynomial does a negative. So I'm going to put a negative in front of these, and we're going to see what the graphs do. And hopefully, if we're right on our assumption that it's just going to take the inverse, if it was going up, it's going to go down. And if it was going down, it's going to go up, if that holds true here. So let's look at the odd versions first. Notice before, when it was positive x cubed, it was down on the left and up on the right, but now it's up on the left and down on the right. Why is that? Because a negative doesn't produce a negative when you take the inverse. A negative produces a positive. You're all of a sudden throwing an additional negative in there, and they're pairing off with one another, and they're going to become positive. Vice versa, you're going to have all positives, but then one negative at the end is always going to be a negative. So it flip-flops, it rotates on the y axis here. And instead of going down on the left, it goes up. Instead of going up on the right, it goes down. And the same thing holds true for all of these odd numbers. So when you have a leading coefficient that's negative, it takes the original graph and does the inverse to it. Let's see if that holds true on the even numbers. Remember, if a on a quadratic told you it went up or down, when we had a negative, it took the parabola and flipped it upside down, right? So let's see if that holds true. If we're always going to have the positive numbers become negative when they're even, yes, because the only negative that occurs in there is going to be that one out front, because they're always going to cancel each other out because there's an even number of them. So all of the graph faces down when you have a negative. So the same holds true in polynomials. That leading coefficient, when they're even numbers, just like a quadratic, it's going to tell you whether it goes up or down. Now the part that's a little new to us, but not so much, if we look at it a line, we went from the positive version to the negative version. They were just flipping. One was going up, one was going down. But let's look at it from left to right. It was going down to up, and now all of a sudden it goes up to down. So a negative leading coefficient starts on infinity and drops to negative infinity, as opposed to the other way around, where it starts at negative infinity and goes to infinity. So let's take what we just learned there and write some rules here. So first thing I want to do is, based on those graphs we just looked at, let's create some rules. So what do I want to look at? Well, first, what cases are there? And the ones we identified were, was the leading coefficient positive or negative? And then the highest degree term, was it even or odd? Because those were the two things that affected the graph. That highest degree term being even or odd affected the graph, but they all mimicked each other. And then the leading coefficient being positive or negative also affected the graph by taking the inverse. So let's look at the first one. The first possibility is the degree is odd and the leading coefficient is positive. Okay. The second one, the degree would be odd, but the leading coefficient is negative. Then we look at the third one. The degree is even and the leading coefficient is positive. And then the last case is the degree is even, but the leading coefficient is negative. So these are our four cases here. Let me zoom out because you were probably writing those down. The degree is odd, but the LC is positive. The degree is odd, the LC is negative, and LC is the leading coefficient. The degree is even, but the leading coefficient is positive, and then the degree is even, and the leading coefficient is negative. So of all of the two things that affected, and we looked at all those different orders, we're going to come up with four scenarios that the graph could do. So we need to understand these from what we were just looking at with the Desmos calculator. So let's draw some things down here of what it does. So if you remember, if the degree was odd, so that was like x cubed, x to the fifth. When we were looking at those, let me put the Desmos back up here. Remember what they did. And so let me take the negatives out of here really quick. All right, so let's look at these individually. First, we're going to look at the degree is odd. Now remember this, you have to have it in standard form. So you're only looking at the first term, the biggest degree possible in that polynomial. That's the one we care about. So let's look at the stuff we did on the graph, the Desmos calculator. We want to know when it's odd, but it's positive. So these are all positive here. So these are the positive ones. But when they're odd, what happens to the graph? Notice on the left side, they point down, and on the right side, they point up. So we're just going to draw that here. So when the degree is odd, I have an odd number of negatives. Then on the left side, I'm going to go down. And on the right side, I'm going to go up. Okay? So whether it's a line or x cubed or x to the fifth or x to the seventh, the ending of the graphs are going to look like this. So this is just the ending part. What happens here in the middle can change, but the ending part is going to shoot off to negative infinity on the left side and positive infinity on the right side. Okay, that will always happen. What happens when the degree is odd, but the leading coefficient is negative? Remember, in the Desmos calculator, what happened there was we did the inverse. If we put a negative out in front of those, remember it flipped it the other direction. So it did the opposite. So in on the left side, instead of going down, it went up. And on the right side, instead of going up, it went down. So what we're going to do here is on the left side, instead of going down, it goes up. And on the right side, instead of going up, it goes down. Now again, in the middle, all kinds of things can happen differently there. But we're just talking about what the ends of the graphs look like. So going off to negative infinity, it goes up. Going off to positive infinity, it goes down. Now let's look when the degree is even. So when the degree is even and it is odd, we're going to go down to the bottom one since Desmos is already set up that way. Oh, no, it's not. We just did that for the negatives. Never mind. All right, so what I'm going to do is I'm going to turn these, for the odds, I'm going to turn these off, and I'm going to turn the evens back on. So evens, remember, like a parabola, if A is positive, it goes up. That's the same case for all even polynomials. So if that leading coefficient is positive, it's going to face up in both directions. Okay, in both directions. Now again, a lot can happen in this middle part, and we'll look at what happens later. But in this middle part, they'll both go up because you're going to have an even number of negatives. They'll cancel each other out, and it'll end up going positive on both sides. Now remember what happens when it was negative. Instead of doing a going up, when you do the inverse, it ends up going down. So this all switches to going down when you have the leading coefficient be a negative number. So just like in quadratic, when A was negative, everything went down. The only difference here is a lot can happen in that middle part depending on what kind of polynomial it is. But the ending parts of the graph, that's what I want to emphasize here. All four of these are just talking about the ending parts of the graph, not what happens in the middle. We'll look at that later. I just want you to understand these ending parts are these four patterns. So I'll review them again. If the degree is odd, but the leading coefficient's positive, it's left side's going to go down, right side's going to go up. Degree is odd, the leading coefficient's negative, it does the inverse. So it goes up on the left and down on the right. When it's even, like a quadratic, like a parabola, if it's positive, it goes up. If it's negative, it goes down. That's really all you have to know about the ending parts. So what we're going to do here is the degree will also tell you how many turns possible. So what is that? What do I mean by that? So if we look at the example x cubed. So x cubed, let's look at our rules here. It's odd, so the degree is odd. So it's going to be one of these two, but it's positive because it's positive 1. So it's going to go down to the left and up to the right. So I know it's going to go down to the left and up to the right. But this tells you how many turns it could possibly have. So it can look like this. You take the highest degree term, which is 3, and subtract 1 from it. And that'll tell you how many turns. So notice if we follow from the left side here, I'll do it in different colors so you can see me go along here. As I am going up from the left, I make my first turn. I start heading down, but then I make another turn and I start going up. So this is 1 turn. This is 2 turns. So x cubed can have at most 2 turns in the graph in that middle part, because you take your highest degree term and you subtract 1 from it. So let's look at x to the 7th. Now this is odd, so it's going to go down on the left side and up on the right side because it is positive. So if I take my turn 7 minus 1, I get 6. So the most turns this can have is 6. So I'm going to follow it. 1 turn, 2 turns, 3 turns, 4 turns, 5 turns, 6 turns. So it can have 1, 2, 3, 4, 5, 6 turns in it at most. Now they can look all kinds of different. I'll give you an example. It could look, one turn can be bigger than the other, like that. You can have an x to the 7th graph look like this. It doesn't have to be even number of ups and downs on distance, but the number of turns that it can happen are limited based on the degree. And the most you can have is the degree minus 1. So let's look at it from an even standpoint. And let's do that over here. Let's look at x to the 6th. Now this is a even and it's positive, so I know it's going to shape and it's going to go up on the left and up on the right. But the number of turns it can have is 6 minus 1, which is 5. So I can go 1 turn, 2 turns, 3 turns, 4 turns, 5 turns. So I have 1, 2, 3, 4, 5 turns at most in a polynomial with a 6th degree term. Okay, because you take 1 away from it, and that's the most turns that graph can have in the middle section. Now the ending parts are what we learned just a few seconds ago, but that middle part, we're talking about the number of turns that can occur. So if you see a graph, you count up the turns that it has, you then know what degree that polynomial is based on the amount of turns that it has. All right? All right, so what I would like you to do now is you're going to use this information. You're going to use this information about if the degree of the largest term is odd or even, you need to know what the graph does. Also, the leading coefficient, if it's positive or negative, how does that affect the graph? So I'm going to give you some practice here. And what I'd like you to do is go into your Schoology folder under this week's folder, and you will see a link to a quizzes. In that, you will get some practice on the graphs of these polynomials. So if you look at your notes, as long as you understand what they do, if it goes up or down on the left or right side, and how many turns it has, you'll be able to answer these questions in that quizzes. So you will get a chance to do this over and over so you can learn from your mistakes. So go ahead and take time now to do the quizzes. I hope you have a great day, and I will see you when I get back.